Hello everyone, myself PIYUSH and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Microprocessor and Microcontrollers, which comes in third year, 6th semester. Right now we are starting our chapter number 3, that is 8085 interrupts. So in this chapter we are going to study different types of interrupts, and this is the module number 3.1. So starting with the flow of content. So in this video lecture we are going to see the necessity of the interrupts, then after different types of classification of interrupts, and maskable and non-maskable interrupts, and vectored interrupts. So what are the vectors interrupts? So starting with the necessity of interrupts. So when you have one or more input output device connected to a microprocessor system, any one of them may demand service at any time. Anyone may demand service at that time, because we have number of input output devices, right? So the microprocessor can service these devices in one of the two ways. That is, one way is to use polling routine and the other way is to use an interrupt. So microprocessor have two ways to service this. One is the polling routine and the second, that is the interrupts. Now we will see both the ways. Okay, so in the polling, the microprocessor software simply check each of the input output device very oftenly. Okay, so what is going to do in polling system? The microprocessor is going to check each and every device at so often times of period. Okay, and during this check, microprocessor test to see if any device needs servicing. So it is going to see whether the input output device is working properly or it needs servicings. Okay, then after, a more desirable method would be the one that allows the microprocessor to be executing its main program and only stop to service input output device when it is told to do. Okay, when it is told to do. So by the device itself, so whenever we are saying microprocessor that it has to service its input output device, at that time only it is going to be services, otherwise the program is working in healthy conditions. Okay, so in fact the method would provide an external asynchronous input that would inform the processor that it should complete whatever instruction that is currently being executed and fetch a new routine that will service the requesting device. Okay, so it is not going to affect our execution of the instructions, right? Once this servicing is completed, the processor would resume exactly where it is left off. So processor is resume its function or its set of instruction from where it is left off before servicing, and this method is called as a interrupt method. Okay, so this is called as a interrupt method. Now we are going to see the classification of interrupts. So we have total two types of interrupts, that is single level interrupts and multi-level interrupts. So we are going to see first, that is the single level interrupts. So in single level interrupts there can be mainly interrupt device, many interrupt device. Okay, that can be many interrupt device, but all interrupts requests are made via single input pin. What is the sentence over here? All the interrupt requests are made via single input pin to MPU. Okay, and when interrupted, MPU has to poll the input output port to identify the request device. So MPU has to request, or MPU has to poll the input output port to identify the requested device. So whatever the requested or whatever the input output device required servicing. So the polling software routine that check the logic state of each devices. Once the interrupting input output port is identified, the MPU will service it and then return to task it was performing before the interrupt. So it is going to start where it is going to be left. Okay, so this is for the single interrupt pin, and remembering this term, that is in single interrupt pin there are many interrupting device, but all the interrupt requests are made via single input pin to the MPU. Now figure shows the single level interrupt system. Let's see the figure, then we are going to discuss it, in which the interrupts request for all the devices are logically ORed. All the devices are logically ORed. Okay, over here We have term odd, and connected to the interrupt input of the processing. Thus, the interrupt request from any device is routed to processor interrupt input. After getting interrupted, the processor identifies requesting device by reading interrupt status of each device. Okay, so let's see the figure of single level interrupts. Over here, as we can see, this is the input output device 1, this is the device 2, this is device 3, and up to n. All the signals from that interrupt device is directly ORed and given to a single pin of microprocessor MPU, and given to the single pin of microprocessor MPU, that is INT, interrupts pin. And this is the input output port and data buses. So whatever the instruction is going to be executed, it is going to be executed through device 1, 2, 3 and 4, whatever the input it is getting or giving to that devices. Okay, suppose device 1 is an input device, device 2 is the output device. So whatever the instruction is running, it is going to function respect to that. And whenever interrupt is going to be occurred in any n number of device, at that time it is going to identify that interrupting devices, and it need to be polling, right? It is going to call as a polling process. So it is going to polling and identify that device, and then service that device, and then again execute the remaining programs. Okay, so this is called as a single level interrupt system. Next one, that is the multi-level interrupt system. So in multi-level interrupt system, the processor has more than one interrupt pins. What is the function over here, or what is the main difference? That is more than one interrupt pins. Okay, the input output device are tied to individual interrupt pin. Okay, the input output device are tied to individual input pin. So in figure we can see that there are different types of input output device, and all the input output device are connected on different pin, not same as in single level interrupts. Okay, in single level we are ORing all the pin and given to the single pin, but in multi-level we are not ORing all the pins, but we are giving individual pin to individual input output devices. Thus the interrupt can be immediately identified by the MPU upon receiving an interrupt request. So whenever which device is going to give interrupt, at that time the MPU is going to identify immediately, and this allow processor to go directly to that input output device and service it without having poll first. Okay, without having poll first, because we are not ORing, or we have separate pins for all the input output devices. So this obviously save the time in processing interrupts, and figure shows the multi-level interrupt system. So let's see the figure also. So here this is the same as single level interrupts, but in multi-level interrupts we have different number of pins. So in device 1, input output device 1, we have pin that is INT1. For device 2 we have pin that is INT2. For device 3 we have pin INT3, and up to device n we have the pin number INTn. So we are not ORing these all the pins, but we are separating all the pins in MPU. Okay, so whenever, suppose let's say that the input output device 2 is going to get some amount of interrupt signal, so it is going to directly given to the INT2 pin, and the CPU or the MPU is know that the device 2 is going to be interrupt requested, and it is going to service that interrupt, and then after the execute the program from where it is going to be left. Okay, so this is the main difference between single level and multi-level interrupt system. In multi-level interrupt system, when a processor is interrupted, it stop executing its current program. Okay, so it is basic in all the system that whenever the interrupt is going to be executed, it is going to stop its current execution program. Okay, and call a special route which service the interrupt. And so whatever the interrupt is occurred in which device, let's say device 2, device 3, or whatever the device required service, so it is going to perform that service to that interrupt. Okay, the event that caused the interruption is called interrupts, and the special route which is executed is called interrupt service routine. The special route that is called as a interrupt service routine. When the external asynchronous input, that is interrupt input, is assessed, a signal is sent to interrupt input. A special sequence in the control logic begins. Okay, so special sequence is going to be begins to service that interrupt routine. Now the processor complete its current instruction no instruction is cut off in the middle of that instruction. So whenever the instruction is going to be executed, at that time the processor is going to be complete that instruction. Let's say it is going to store some data or move some data, or it is going to be as a taking as a input output device. So at that time it is going to read some data, so that execution is going to be completed. So no execution is going to be cut off in middle. Then second one, that is the program counter current content are stored in the stack. Program counter current content is going to be stacked. Remember, during the execution of the instruction, the program counter is pointing to the memory location for the next instruction. So program counter is pointing toward the next location in memory. Next one, that is the program counter is loaded with the address of interrupt service routine. Okay, so program counter is loaded with the address of whatever the interrupt service is routed. Next one, that is the program execution continues with instruction takes from memory location pointed by the new program counter context. Okay, so this is the process, and let's see the next 2 points also. This is the flow of points, how the servicing is going to be done. Next point, that is the interrupt program continues to execute until the return instruction is executed. So interrupt program is going to be continued to execute until the return instruction, whenever the return instruction is going to be executed. And last one, that is the after execution of reset, that is RET instruction, processor gets the older address, that is the address of the next instruction from where interruption service routine was called. So where it is going to be stopped, after that stop point it is going to start from the same point of the program counter from the stack and interrupt it back into the program counter. This allow the interrupt program to continue execution at the instruction following the one where it was interrupted. So the figure shows the response of the interrupt with the flow chart. Okay, let's see the figure. So here is the flow chart of that interruption circuit. So assets interrupt request line. So whenever interrupt is going to be occurred, the complete execution of the current instruction. So whatever the instruction is going to be executed at that time, it is going to continue it. So right now we can say that we have program like this 1 2 3 4 lines program, or let's take more lines of this program. Okay, so at this point, if interrupt is going to be occurred, at that time the program is executing, completing this execution first, then after it is going to start the interruption process. So whatever the interruption process is going to be occurred, let's understand by this also. So this is the main program flow, this is the main program flow, and at this point we have interruption or push the PC, that is interruption is going to be occurred. Okay, so from this point it is going to start the interruption service routine, and when it is going to be reset, at that time it is pop up to the program or where we have left the program and starting the execution of the remaining program. So let's say the complete the execution of the current instruction. Then after we are going to see the put current program counter value on stack. So we are putting our program counter value into the stack. Then after load the program counter with address of interrupt service. So we are going to load the program counter with the address, whatever the interrupt we are going to be done, or we are executing whatever the interrupts is occurred, we need to store that into the program counter. Next, execute the interrupt service routine. So we are going to execute this interrupt service routine. Then after return from the interrupt. So whatever the return from interrupts, it means we need to return that is reset and return to our main program, that is the continue where interrupted. So over here it is interrupted, so it is going to start from here. So the main flow is going to be look like this program is going to be continue, and then after whenever the interrupt is going to be occur, it's going to be in this direction. Then after the main service routine is done, then after the reset, it is going to pop back to the PC and it is going to start like this. So from where it is going to be left. So this is called as a response of interrupt with the flow chart diagram. This is the called as a response of interrupt with flow chart diagram. So remember this flow chart also. Next, we are going to see the maskable and non-maskable interrupts. So maskable interrupts are enable and disable under program control. Maskable interrupts are enable and disable under program control, and by setting or resetting the particular flip-flop in the processor, interrupt can be masked or unmasked respectively. When masked, the processor does not respond to interrupts even though the interrupt is active. Okay, remember this, whenever we are masked, whenever we have the mask, processor does not respond to interrupts even though the interrupt is activated. Okay, and most of the processor provide masking facility. Okay, most of the program or most of the processor provide masking facility. The processor those interrupt which can be masked under the software control are called maskable interrupts. So remember these definitions. The processor those interrupt which can be marked under the software control, under the software control are called as a maskable interrupt, and the interrupt which cannot be masked, which cannot be masked under the software control are called as a non-maskable interrupts. So most of the processor are maskable interrupts. Okay, right now we are going to see the vector interrupts. Vector interrupts, when the external device interrupt the MPU interrupt request, at that time MPU has to execute interrupt service routine for servicing that interrupt. Okay, that's it. If the interrupt control circuit of the processor produce a call to predetermined memory location, which is the starting address of the interrupt service routine, then that address is called as a vector address, and such interrupt are called as a vector interrupt. So whenever we are going to execute any kind of interruption, at that time the processor circuit has a call that is predefined memory location. Okay, predefined memory location, it is going to start our interrupt process, or we can say interrupt service routine from that predefined location in the memory. At that time this is called as a vector address, and these interrupt are called as a vector interrupt because it is predefined in the memory also. Now, for the vector interrupts, fastest and most flexible response is obtained, since such an interrupt cause a direct hardware implemented transition to the interrupt service routine. Okay, because it is already there in the memory of that address point. This technique is called as a vectoring, and figure shows the widely used of vectored interrupt scheme. So let's see the figure. This is how vectored interrupt scheme is given as. So over here this is the interrupt request line, and over here interrupt mask register. So whatever the marked registered are done, that is over here, and this is the interrupt register. So it is ANDing and NOTing this. This is AND, it means one of them need to be true, right? ANDing means one of them need to be true, and it is going to be the MPU, that is priority encoder, and from the priority encoder it is going to give to the address to the PC, whatever address to the PC, and input active is going to give the output to the interrupt that is going to be pending. Okay, so this is called as a vector interrupt scheme. Now as shown in figure, interrupt request signal are stored in the interrupt registers. The programmable interrupt mask register is used to disable any or all the interrupt request line. Now, for any AND gate, remember this line sentence, for any AND gate, one input is interrupted request signal from the interrupt register, and second input is the inverted masked condition for the same interrupt from the interrupt mask registered. When any interrupt is masked 1, the input to AND gate is 0, and hence the output is 0. So let's see in figure also. Over here suppose we have this signal, that is this is 1, and over this is also 1 dash. So at that time what's going to be happen, this 1 is going over here and this 1 is going over here. So this 1 is over here and this is 0 over here, so the output is going to be 0, right? So again same, that is the same for the 1, this is 1 and this is 1. For here this is 0 and this is 0, so for ANDing both need to be same. At that time the output is going to be 0, sorry, output is going to be 1. So if one of them is 0, at that time the output is going to be 0, and this means that the interrupt is marked, and this is the mean that the interrupt is marked. The corresponding interrupt request line is disabled when interrupt request is present for marked interrupt. This that is fed into the priority encoder which produce the address which is then inserted into the program counter. So remember this sentence as well. Okay, that's it for this interrupt. And in this video we have studied successfully the what is the polling, what is the mask interrupt, what is single level and multi-level interrupts, right? So here are some questions regarding that this video lecture. So what are the interrupts that is asked for 2 marks? Then after explain the term polling and with suitable examples. For example, we have to draw the flow graph, okay, and give the classification of interrupt. What do you mean by the multi-level interrupt? So we have to give the classification and explaining multi-level interrupts in details. Then after define maskable and non-maskable interrupts. So we have to define it with suitable example also. And what is the meant by the vector and non-vector interrupts? We have to define this as well with the suitable example. And that's it for this video lecture. If you find any kind of query regarding this, then please ask me. Thank you.